US Physics Olympiad, year 2011, F equal MA, first round. Problem 18. Solution for this problem you can find below this video on the reference in the description. A block of mass m equal 3 kg slides down one ramp and then up a second ramp. The coefficient of kinetic friction between the block and each ramp is μk equal 0.4. The block begins at a height h1 equal 1 meter above the horizontal. Both ramps are at 30 degrees incline above the horizontal. To what height above the horizontal does the block rise on the second ramp? Solution. First, let's draw the picture. Initially, block starts to slide on the first ramp from height h1, moving against the force of friction, and after that rising up on the second ramp, again moving against the friction. So here we can use work energy theorem. It means that initial potential energy equal final potential energy plus work done by force of friction. So force of friction as usual equal mu multiplied by mg cosine theta, where mg cosine theta, that's a normal force. And now we can write a full equation for our problem. Now full equation looks like this. mgh1 equal mgh2 plus work done by force of friction, which is force of friction multiplied by total distance on the first ramp, which is h1 over sine theta, plus force of friction multiplied by second distance, which is h2 over sine theta. From here we can find what is h2. We can rewrite this equation in form of this one, and from here find what is h2. Finally, we have h2 equal this expression, and after simplification and putting numbers, we will get 0.18 meters, which is answer A. Problems 19 and 20. Questions 19 and 20 refer to the following information. A particle of mass 2 kg moves under a force given by equation F equal -8 newtons per meter multiplied by xi plus yj, where I and j are unit vectors in x and y directions. The particle is placed at the origin with an initial velocity v equal 3 meters per second by I direction and 4 meters per second by j direction. Questions 19. After how much time will the particle first return to the origin? And question 20. What is the maximum distance between the particle and the origin? Solution. If we can see from this equation, we have force proportional to displacement and going in opposite direction to this displacement. It means that this force exactly describing harmonic oscillations. And we can write equation MA equal -kr. So here we have mass 2 kg and K equal 8 Newton per meter. So we can rewrite in the form of this one. And from here we can say that omega square equal 4. Means that omega equal 2. And the period equal 2 pi over omega, which is 3.1 14 seconds. And our body will return to the origin after half of period, which is t/2. That's 1.57 seconds. Correct answer is C. What is the maximum distance between the particle and the origin? That was question 20. Here we can write equation for energy transformation. In the origin we have total energy is kinetic energy of this particle, which is 1/2 mv square, and for the maximum distance we have potential energy equal 1/2 k r square. So let's write this equation. This is our energy equation. 1/2 k a square equal 1/2 mv square. From here we can find what is amplitude A. Total amplitude or maximum distance equals square root from m over k multiplied by the speed of this particle in the origin, which is 5 meters per second. We can find it from this equation. So total maximum distance will be 2.5 meters, which is answer B.